Dude, I don't get why only AMC and Yusuko actually release their test right after the competition. It's so triggering, god dang it. I want to go over FMA, I want to go over Yusubo, but no, they really got to do it like this. But it's okay. I anyways need to study math. Okay, that's the one thing that I want to study this year. So we might as well get into some more math. Hello everybody, I'm Karar, and today we are going to be going over the AMC 12B problem because you guys seem to like me going over the 12A problems, and honestly speaking, like, these ones were pretty cool. There were some epic geometry ones, so why don't we just get into it? Alright, number one, how many integer values of x satisfy absolute value of x is less than 3 pi? This one was actually kind of hard, bruh. Like, honestly speaking. So, essentially, you just know that 3 pi is like 3.14 times 3, approximately 9.42 or some nonsense. So essentially, you could go from negative 9 to positive 9, which is just 18 plus 1 is equal to 19 numbers. Very cool. Watch me have gotten number 1 wrong. That would have been so sad. Holy moly. Okay, we are chilling. At a math contest, 57 people wearing blue shirts, another 75 people wearing yellow shirts. 132 are assigned into 66 pairs, okay? And in 23 of these pairs, both are, okay, so essentially 23 of them, this is kind of like Hardy-Weinberg equilibrium. Why am I bringing bio into this even? So, 23 of them have the dominant blue allele, and that means that there's 46 total blue alleles in this thing. Oh gosh, stop. Okay, but like total, so that means that there are how many students left? We subtract 46, we get like 86, right? And then essentially, how many blue shirts? So 57, so there's 11 more blue shirts to go around. So that means there's 11 blue and yellow pairs, right? So that means minus 11 from, so basically minus 11 from 75, we have, what, 64 then, right? So basically this is the number of yellow shirts that are in yellow only pairs, which means there are 32 pairs, which should be B. Wait, did I get this wrong? Wait, did I? I forgot. I think I got this right. Okay. I really hope I didn't get this wrong. I don't remember. That would be very sad. Okay. Then the next one is, suppose this. Okay, this is just a really nasty algebra nonsense. So essentially you just do, actually not that nasty. You could go the other way. I think it's faster. So essentially you do 144 over 53 minus 2 is like minus 106 is, I can't math, 28? No, 38. Okay. And then, you take the reciprocal of that, so it's 53 over 38, then you subtract 1 from this, and you get like 20, or 15 over 38, which is 38 over 15, then you subtract 2, right, so that means 8 over 15, take the reciprocal, so 15 over 8, and now that is equal to 2 over 3 minus x, and then we multiply 45 minus 15x is equal to 16, so that just means that we have 29 over 15. No, did I troll? Oh, there's a 2. Wait, what? So it should just be, 8 over 15. Because you don't take the reciprocal for this last time. It should be 8 over 15 is equal to 2 over 3 minus x, which gives you 24 minus 8x is equal to 30, which means that x is equal to 3 over 4. Wait, am I trolling again? No. Okay, you know what? I think I am big trolling. Wait, what's 3 minus x? That was 3 plus x. Is that just a typo? Okay, so if it was plus x, let's just see. Then it would be 6 over 8, it's 3/4. Is that the right answer? I'm pretty sure it was. Yeah, wait, I didn't make. What? Okay, let's just see. Yeah, it's 3 plus x. That's so troll. What the heck? God dang it. You know, can we edit this? Bro, that's so triggering. God dang it. Whoever did this on AF, I'm very mad at you. Why you gotta do this to me? Wait, what did you even said plus? What? Huh? Is it just like really tiny that way? Okay, now, finally on problem 4, god dang it. Okay, Miss Blackwell gives an exam to 2 classes. The mean of the scores of the students in the morning class is 84. The afternoon mean score is 70. Okay, so essentially there are 3 to 4, so essentially we weighted, right? So the morning class is weighted with 3, and the afternoon class is weighted with 4, and you just divide by 7. And you do some epic stuff. Actually, you don't even need to do epic stuff. Divide by 7, you get 12 times 3. Plus 10 times 4 is equal to 76. Epic. Okay, a point P, AB in the xy plane is first rotated about the point 1,5. Okay, so you essentially have like this, right? And there's a 1,5. And you have a point AB, and reflected about y is equal to negative x. So the image is negative 6, 3. Okay, So essentially we just do it backwards, right? So if you reflect over this, you just like swap the x and y, right? And like the x should still be negative, so this does negative 3 comma 6, okay? And then essentially it is rotated around 1 comma 5. 3 comma 6, 1 comma 5. Oh, okay, so it's down 1 over how much? Over 4. Okay, so 1, 4, and it was rotated 90 degrees counterclockwise, so if we just do that, right? 1, 4, 1, 5. So then this should just be 2 comma 9, which means that b minus a is just 7. Epic. Alright, problem number 6, an inverted cone. Hey, they did water on both of them. That's pretty epic of them. Alright, so you got an inverted cone, you got base radius 12 centimeters and height 18 centimeters. Full of water, you pour into a tall cylinder, radius 24 centimeters. What is the height? Okay, this is just like, bruh. So your volume of the cone is pi times 12 squared times 18 over 3, and then that is equal to pi times 24 squared h. So if you just divide, then it's just like 6 over 4 is equal to 3 over 2, which is 1.5, which is A. Alright, number 7, n equals 37, that's not 37, 34 times 63 times 270. What is the ratio of the sum of the odd divisors of n? Alright, problem number 7 is pretty cool, not gonna lie. So essentially, you're like, okay, so the even divisors, well, let's just factor this out first, right? So there's like 3 2's, right? So 17 times 63 times 135, okay. And then, what do? So essentially, you know, well, let's just factor it out fully. So there's like 3 3's in here, 2 3's in there. So should be 3 to the 5 times, there's 7 there, then there's 5 there, whoops. And then 17 squared, okay, and then 2 cubed. So the sum of the odd divisors are basically the sum of these dudes, but then, like, for each, for the sum of even divisors, you can multiply each divisor by 2, you can multiply it by 4, or you can multiply it by 8, right? So you could have, so there's odd divisors, which will be like 3, 5, 7, etc. But our even divisors is equal to like 2 times odd plus 4 times odd plus 8 times odd, right? So essentially, if we do the ratio of the sums, right, then you just do like, well, basically it's like 3 plus 5 plus 7, and then you can see, right, like, if 3 is a factor, then 2 times 3 is also a factor, so that is why this makes sense. So essentially you just do odd over 2 plus 4 plus 8 odd is equal to 1 over 14, which is C, epic. Alright, this one, dude, geometry is cool. Okay, so we got 3 parallel lines. So the 38 means that they're like equidistant from the center, right? Because essentially your chord length literally only depends on the radius of the circle and distance to the center. So they're equal distance here, like let's say AA. Then the next one will have to be 2A away, right? Because they're equidistant, 2A. This is not to scale. As you might expect, my diagrams are epic. So essentially, like, if we just set this to be R, right, then we essentially know that, this is 19, this is, 17. So we know that 17 squared plus 3A squared is equal to, r squared, and then we also know that 19 squared plus a squared is equal to r squared. So if we want to solve for a, we can just subtract. So you get like 19 squared minus 17 squared is equal to 8a squared. And if you just if you do the difference of squares, it's pretty easy. So it's like 2 times 19 plus 17, which is 36, right, is equal to 8a squared. So that means that a is equal to 3, which means that the distance is just 2a. So it should be B. Very epic. Alrighty. Number 9. What is the value of this nonsense? I think this is a pretty cool one, right? I don't remember it exactly though. I think this one took me a while to figure out though. I don't know why. Well, okay, so first off, you could like find a common denominator, right? So essentially you do like log 280 log 22 minus log 2 160 log 42, and then like the denominator is log 42 log 22. So essentially like you could flip the bases, so essentially it becomes log 20 of 80 minus log 40 of 160 over log 40 of 2 log 20 of 2. Then essentially it's just like what? So technically you could do like the like log over log thing. So you could do like log 80 or log 20 of 80 is equal to log 80 over log 20. Basically, if you don't know what to do, always just do this because like it makes it kind of nasty, but also like it automatically you don't have to remember any of the log rules like the switching bases and stuff. It's like obvious from here if you just write it like this. So if you write it like that, then there'll be like a log 2 squared in the denominator, right? And then it'll be like um log what? Log 20, log 80 minus log 40 log 80 and log 20 log 160. That's why if you plug in here, you'll see that it cancels out to that. And essentially if we just make all of these base log 2, because we could, right, then this just becomes like log base 2 of 40 log base 80 minus log base 20 log base 60. Honestly, I think if I remembered how I did it, like we could probably just get to the answer directly, but I don't remember how I did it. So we get to go through the entire live solve. It's very epic. Oh yeah, okay. So the idea is like you could set this to be log what? Log 2 of 2 plus log 2 of 20, right? Just by like log multiplication rules, right? Because it is the same thing as log 2 times 20 times log 80 minus log 20 times log 2 of 2 plus log 80. So this cancels out with that, right? Or sorry, yeah, basically. Or we could write it like this. This cancels out with that. And then you're left with log 80 minus log 20, which is just log 80 over log 2 of 80 over 20, which is equal to log 2 of 4, which is equal to 2, which is D. Hey, we did it, boys. Alright, two distinct numbers are selected from the set, okay, so that the sum of the remaining 35 numbers is a product. Okay, so essentially, like, you find the total sum, right? The total sum of 37 times 19, and the two distinct numbers, so let's say x and minus y, is equal to xy. And if we be cool kids, we could basically write this as like what? Whenever you see xy and x, like an xy and an x and a y, then you basically just write it as Simon's favorite factoring trick. It is the best way to do it. Is equal to, whoops, plus 1, 37 times 19 minus 1, or sorry, plus 1. So let's just calculate that out, and then we essentially just need to find two numbers, two factors of whatever this is that fit in this range. This is equal to 3, 6, 2, 7, 3, 3, really? Oh yeah, okay, that makes sense. And then 7, 3, 3, 0, 1, 7. 703, okay. So 704 is basically equal to, divide by 2, you get like 352, or divide by 4, we probably should. So that gives you 1, 3, 0, 7, 2, 4, 6. Ah, no, wait, 176 over 4 is 4, 164. Oh my god. So it's divisible by 4 cubed, okay, times 11. Oh, really? I did not know that. Alright. Wait, I'm so bad. It's literally 7 plus 4 is 11. Alright, I should have noticed that. But essentially, it is 4 cubed times 11. So we need both of them to fall in. So we could say 22 and 4 to the 4 cubed over 2, which is equal to 32. So 32 and 22 both fall in the range, and the difference is just 10, which is E. Hey, they made the answer to 10, 10. Wow, how cool. Hooray, a 13, 14, 15 triangle problem. Dude, the first time I saw a 13, 14, 15 triangle problem, it was so stupid because, like, literally, you gotta notice, like, the 13, 14, 15 triangles have, like, these cool properties. Like, nobody, like, how do you notice that, like, this is supposed to be 5, 9, 12, 15? Like, but once you know this, it, like, helps a lot on these kind of problems. Imagine using Heron's formula every time you want to find the area of this triangle. That's very sad. Okay, so let P be the point on AC such that PC is 10. So what are our sides? So A, B, C. And then on AC such that PC is 10. So there's a 5 and that's 10. So then there are, okay, there's a P, and then there are 2 points D and E such that A, B, C, D, A, B, C, D. Oh, it's on line B. Okay. So essentially, this could be parallel to that, right? Or you could have AB is parallel to whatever the heck that is. Oh man, I hate drawing diagrams. Okay, pretend that was a very good diagram. Well, in this case, like if it's this trapezoid, then it's pretty easy, right? Because it's just like 5 to 10, or is that easy? Yeah, because this triangle is similar to that triangle, so you just divide by 2, right? So it's asking for the distance, so we're asking for this distance right there. Well, I mean, I guess that's not that easy. So we had to find like some lengths. Hey, that's very helpful. Let's see. So this length is just gonna be that length. Wait, what? Oh, that length is kind of nasty though. Well, I guess you could use Stewart's to find it eventually. Okay, let's just call it x for now. So if that's x, then this is gonna be x over 2, right? Because that's 5 and this is similar, right? Okay, and then if we have this one over here, this is similar to that. So eventually this gets doubled, right? Because it's going from 5 to 10. So now this whole thing is 2x, right? So the distance between them is just like 3 halves x. So if we find x, we should be chilling. So eventually we have our 13, 14, 15 triangle, very epic. And we want to find the length of this, where the 5 is 10. Is there an easy way to do this without Stewart's? I hate Stewart's with a passion. No, I don't want to do Stewart's. There's literally no way to do it without Stewart's. Okay, we're doing it with Stewart's. Hooray. Bruh. So, I mean, I never memorized Stewart's. Like, I know it's like a bomb and a man in a sink or something. I don't really care. I'm just going to do log cosine. That's how I do it every time. So, essentially, you have like 14 squared plus 15 squared minus 2 times 14 times 15. Cosine C is equal to 13 squared. So, essentially, if we want to find 10 squared minus 14 or plus 14 squared minus 2 times 14 times 10, cosine C is equal to x squared. Then essentially we just plug in here, we get like 10 squared plus 14 squared minus 2 times 14 times 10 times 14 squared plus 15 squared minus 13 squared over 2 times 14 times 15. Hooray, okay. Now we just simplify this nonsense and we should be good. Okay, 100 plus 196 minus, this cancels out, that cancels out, this becomes a 2, that becomes a 3, and 14, 15, 13. Can we simplify anything easily? Okay, well, difference of squares obviously will give you 2 times 28, so you get like 196 plus 56, which is gonna give you 252 divided by 3 is gonna give you 84, 164, or 168. So eventually we get minus 168, and this will be a difference of 828, so we get 128. Alright, so this is just root 128, and we want to take 3 halves of that. So divide by 4, you get like 32, and you multiply, or sorry, root 32, 3 root 32, which is just the same thing as 12 root 2, which is D. Nice. Alrighty, suppose that S is a finite set of positive integers. The greatest integer in S is removed. I hate these ones, but they're not that bad. Okay. The average value of the remaining integers is 32. Okay, so let's just call the biggest one A, the smallest one B, because those are very descriptive variable names. And essentially, if we take like the sum of the previous one, so like let's call it S minus A, or actually, or yeah, let's do the sum of the other ones, right? Yeah, that's probably easier. Okay, so sum of all the other ones is S, so we add in B over, let's just say n minus 1, I guess. Well, let's just call it n, so it's easier. N is equal to 32, and then S plus, if the other integer is also removed, then it's just S over n minus 1 is equal to 35, and if the greatest one is also returned, so your S plus A now, over n, the average value is 40. So essentially we eventually want S over n plus 1. Or sorry, S plus A plus B over n plus 1. And essentially we know that A minus B is equal to 72. Okay, so if we just subtract these, right, we can easily get n, right? Because you get like A minus B over n is equal to 8, which means that n is equal to 9, right? So if there's 9, then we can just plug it into all of these, and we basically get S over 8 is equal to, what? Is equal to 35, okay. And that gives you S is equal to 20 to 260. Wait, no, I know how that, okay, 280. And then the other one was like 280 minus A over 9 is equals to 32, or 280 plus A is equal to 40. So 360, subtract 280, and you get A is equal to 80, which means that B is equal to 8. Which means that this value over here is just going to be equal to 280 plus 88 over 10, which is equal to 36.8, which is D. Nice. Okay, yeah, this one was kind of cool. Like, If you try to do algebra on this one, it's going to be really, really nasty. But if you just graph it, whenever you see trig functions, you should probably try graphing it first. But essentially, this is the same thing as 1 minus 3 sine theta, or we could say like 3 sine theta minus 1 is equal to 5 cosine 3 theta, right? So if it's basically finding the intersection points of the graph between 0 and 2 pi. So between 0 and 2 pi, like 3 sine theta minus 1 kind of looks like that, right? And that's like negative 1. And then 5 cosine 3 theta, it looks something like this. It goes down, up, that's 1 period, 2 periods, 3 periods. That's how it looks, right? So clearly, just like counting the number of intersection points, 1, 2, 3, 4, 5, 6, and the answer is 6. Epic. Dude, I don't know. For some reason, I thought that graphing was like cheating, kind of, because it's like kind of troll. But it actually works. It's a legit strategy, and it's actually kind of good. A, B, C, D. Let DM be a segment perpendicular to the plane. Okay, so, oh, dude, this one. No, this one, dude, this one's wasted so much time for me. Oh my god. Holy. Let's see if I can find its faster way this time. So, A, B, C, D. You got your M flapping out here. And you got DM is integer length, so let's just say it's like X. And then length of MA, MB, MC are all integers. Consecutive odd integers, okay? What is the volume? So could we just like, okay, let's just say it's like k plus 2, k plus 4, right? Because obviously MB has to be the biggest, and like let's just assume without loss of generality that this is the smallest one. Oh, it says. Okay, it says. So I mean, it literally tells you. So that is correct. So if we just say this is like A, this is B, we say x squared plus a squared equals k squared. X squared plus b squared is equal to k plus 2 squared, and x squared plus a squared plus b squared is equal to k plus 4 squared. And the idea is we don't want to have to deal with a and b because we don't know anything about a and b. They could be any number whatsoever, so we want to get rid of them. So what we could do is we could add the first two and subtract the last one, right? Is that the only way to do it? I think that's the best way to do it, right? So if we add these, we get like 2k squared plus 4k plus 4, and then we subtract this, and you get like minus k squared plus 8k plus 16, right? So essentially you just get that x squared is equal to k squared minus 4k minus 12. So this right side factors to like what? X squared is equal to k minus 6 times k plus 2. And I guess this is just guess and check, right? You just like find what x could possibly be. Let's try k. What does k have to be? So k just has to be an odd number greater than 6. So let's try 7. That's 1 times 9. Wait, that literally worked. Okay, so our side lengths are 7, 9, 11, and 3. Okay. And what is the volume? Then essentially we can just find like 7 squared minus 3 squared is root 40, right? 9 squared 81 minus 9 is root 72, and if you just multiply these together, divide by 3, you get root 40 times root 72 is equal to the factor on an 8. 8 root 5 times 9 is equal to 8 root 45. Nope. 9 is a square. Very good point. So you get 24 root 5, which is A, and that is correct, I think. Yep. Yeah, I know. Honestly, there was a lot of geometry, but I'm not complaining. It worked out well for me. Okay, so we got our epic pentagon, and we basically got a bunch of equilateral triangle boys. Whoops, probably should be slanted a little bit. Hey, that's a pretty good diagram, I'm not gonna lie. Okay, so they're all length 2. 2, 2, 2, 2, 2, 2, 2, 2, 2. Okay, so I mean, like, obviously the idea is to split it up into things we know, and like, I mean, I can't really unsee it anymore, but the way to split it up is to do this triangle, right? Like this triangle right here, and then these two triangles over there, which are all easy to find, right? Because this is just a 2 by 2 by 2 rhombus. I mean, 2 by 2 by 2 by 2 or something. I don't even know. Okay, like that. So these are just equilateral triangles stuck on top of each other. So that's like 1. That's like root 3. So the length of this is 2 root 3. So essentially we have, this is 120 degrees, so the area of these triangles are just like 1 half times 2 squared times sine of 120 degrees, which is just equal to root 3 over 2, which is just going to be root 3 as that. So we have 2 root 3 from the side triangles, and then we want to find the area of the middle triangle, which is like that, 2. And this big boy is going to be what did we say it was? 2 root 3. Okay, so just by using Pythag, we could say that the 1 is like 2 root 3, which is square root of 12, so this is like root 11. And then the area is just plus root 11. So this is the same thing as root 12 plus root 11, which gives us an answer of 23. Hey. Dude, I don't even know what problem 16 was, dude. It's literally like way easier than all the other ones. Honestly, see, I just went to it and I was like, bruh. Okay, so you have 3 roots, or the 3 roots of that nonsense, and you have 1 is less than A, less than B, less than C. What is G of 1? What's G of 1? Oh, the roots are reciprocals. So I mean, it's literally just the sum of the. Okay, so the A of G, AG, is going to be equal to like sum of the reciprocals of the roots, right? Which is just equal to like R1 over R1 plus 1 over R2 plus 1 over R3, which is equal to R1, R2 plus R2, R3 plus R1, R3 over the product. And you can literally just figure it out. Like the pairwise product is the positive of B, right? So it's equal to B, and then the product is the negative of C. So it's negative B over C, and well, I guess it's a negative A. So that means that A of G is just equal to the negative of this. So this is just equal to B over C. Then B of G is just equal to 1 over R1, R2, 1 over R2, R3, plus 1 over R1, R3. And you could just like see that the R1 plus R2 plus R3 over R1, R2, R3. So this is just the same thing as like negative A over negative C, which is just A over C. And finally, the last one, the last one is going to be C of G, and that is the product 1 over R1, R2, R3, and that is pretty easy. That is just negative of that, which is just equal to 1 over C. So you just add these together, and the leading coefficient is 1, right? So it should be 1 plus AG plus BG plus CG, which is equal to 1 plus B over C plus A over C plus 1 over C, which is just equal to 1 plus A plus B plus C over C, which is A. Noise. Alrighty, number 17. So you have this nonsense, and you got this nonsense. This one actually took me a while. It was kind of cool though, the solution. So A, B, C, D, and you got 5, 3. Okay, so I guess the first thing to note is that the area of the total thing is just like the sum of all these, which is 14. And this is all you know. This is literally all you know. Okay, so I think the idea was like, okay, so let's just say the height of the overall thing is like h, and let's just say this, like what? So we want AB over CD, right? So we can just say that this is like K, A, and then this A, right? And then the area is going to be like 1 plus K A over 2 times H is equal to 14, right? And then if we set this to like H1 and H2, then we could basically find that AH1 over 2 is equal to 2, and AH2 over 2, or sorry, KAH2 over 2 is equal to 4. So you just divide the first two, you literally just get that H1 over H2 is equal to 1 half, right? Or sorry, is equal to K over 1 half, K over 2. And then if we plug that in, or no, what? Wait, we could write H2 as Ka times H minus H1 over 2 is equal to 4. So I'm not sure what the fastest way to solve these equations are, but I'm assuming you just eliminate H1, right? So essentially you multiply this by K, so you get like 2K KAH1. You substitute in here, you get KAH over 2 minus 2K is equal to 4. And then if you plug in for H, which you get is like H is equal to 2K plus 4 times 2 over Ka, or Ka, then you plug it back into the original equation, and you should get a quadratic, right? So the a's cancel out, and you get 1 plus k times 2k plus 4. The 2's also cancel out, and you're left with over k, right, is equal to 14. And if you just solve this, you get 2k squared plus 4k, or plus 6k, plus 4 is equal to 14k. And if we just divide by 2, get k squared minus 4k plus 2 is equal to 0. And if we solve for k, we get k is equal to 4 plus or minus root 4 squared minus 2 times 4 over 2. And then this just becomes 2 plus or minus root 2. Now, the reason why we don't take the minus one is because we're given that AB is greater than CD, so the answer is just 2 plus root 2. Epic. Alright. 18 I didn't even try. I probably do not want to try it, but I mean, we should try 18 just so we get some, like, continuous number, okay? How do we do this? I don't get it. Okay, well, honestly speaking, I tried to, like, bash just plugging in a plus bi for z, but I got lazy, and I was like, nope, we might as well try some of the later ones, which was actually a good idea, honestly, but let's just try it now. So, 12 times a squared plus b squared is equal to 2 times a plus 2 squared plus b squared plus oh god, no, this is gonna be nasty. So z squared is a squared minus b squared plus 2abi. So the magnitude, oh, plus 1. Bro, no, why you gotta be like this? Okay, plus 1 squared plus like 4a squared b squared plus 31. Okay, that looks beautiful. Beautiful, I gotta say. Well, I guess, no, the stuff doesn't even cancel out though. Okay, well, let's just simplify this as best we can. So this is gonna be 12a squared, 10a squared plus 10b squared is equal to 8a plus 8, yeah, and then plus like a to the fourth plus b to the fourth plus 1 minus 2a squared b squared plus 2a squared minus 2b squared plus 4a squared b squared plus 31. Okay. Holy moly whack-a-mole. Okay, 8a squared plus 12b squared. This is so scary. 8a plus a to the 4 plus b to the 4 plus 1, so that's like plus 40 total. Minus 2a squared b, oh, I guess plus 2a squared b squared overall. And that it? Okay, so this is all we got. What do we even do with this nonsense though? Okay, maybe we could complete some squares. Although I did not see any fun completed squares going on here. What could we possibly do? Well, I guess if we're careful, we might be able to do. Okay, so how do we get 40? So it's like 36 plus 4. So if we get 4 somehow. Well, if we get like b squared plus 6 squared or minus 6 squared, that gives you the 36. Then how do you get the 4 though? Oh, the 4 is annoying. I don't think you could get a 4 because then you need a minus 2 somewhere. Oh, there we go. Okay, so the strategy is, what is the strategy? I want to complete the square somewhere, but where do we complete the square? I don't get it. No. Okay, well, let's see if we could find the answer in terms of a and b. So a plus bi plus 6 over a plus bi will give you a squared plus b squared, or a squared minus b squared, plus 2abi over a plus bi plus 6. Okay, which doesn't seem too nice. Well, I'm assuming this has to be 0, right? Wait, so a or b has to be 0 then? Oh, I guess. Oh, that seems nasty though. What's so special about the z over 6 plus z though? I don't get it. So you get like a squared minus b squared plus 2abi plus 6 over a plus bi, right? And if we do multiply by a minus bi, you basically get, oh, we basically know that z and 6 over z are complex conjugates if it's a real answer. So a plus bi equals, 6a minus bi over 6 times a minus bi over a squared plus b squared, which basically means that the magnitude is 6. So, I mean, did that help? Oh, I guess that simplifies this decently, right? So, if it's a squared plus b squared squared, then that is just, oh, it's so big brain. Okay. So now, okay, we made it. Okay, bruh. So that is 6 squared, and then this is just 8 times 6 squared plus 4b squared. Well, we can even simplify that a bit. Instead we could do like 12 times 6 squared minus 4a squared is equal to that. And we were finally, okay, we did it. We did it, boys. Hooray. Very nice. Okay, that's kind of cool. Oh, I guess you kind of got to use the idea that the answer is real. Oh, okay. So you get like 4a squared plus 8a plus 76 minus 36 times 12. 144 times 2? Yeah, 144 times 3. No, 144 times 3. 300, is that 432? Seems legit. And that is just equal to 4, or let's just divide by 4. A squared plus 2a plus, like 19 minus, so that's like 144 over 4, 36 times 3 is 108. Okay, So 19 minus 108. Ah, why is it so hard? I don't like subtracting. Okay, so 9, 8, 1, 9. Okay, 89. Okay, so essentially we got like a squared plus 2a plus like 89. Okay. Is 89 prime or isn't it? Wait, 89 is prime, is it not? Which means that can't be right. Okay, hold up. So we know that a squared plus b squared is equal to 6. So that makes it like 12 times 6 squared is equal to 2 times oh no, a squared. Oh, the magnitude. Oh, the magnitude squared is 6. Okay, that makes a bit more sense. So a squared plus b squared is equal to 6, not 6 squared. Okay. Oh, this is 6 squared. Oh, okay, yeah, that makes a bit more sense. So this is minus 72. So that's plus 4. So a is equal to negative 1, which means that 2a is equal to negative 2. Holy moly, that was a fat problem. What the heck? Okay, that makes a bit more sense. Negative 2, very nice, very nice. Okay, so you write it, oh, if you write it in terms of its conjugates, then it's a lot easier. Oh, bro, that would make so much more sense. Okay. Yeah, because then you could cancel out stuff easier. Bro, what? All these are such simple solutions. Oh yeah, I guess they did that. Nice. Okay. Yeah, that's what I did. Okay, I guess this is a cool way. You just replace it with itself multiplied by its own complex conjugate, and that that makes sense. All right, why don't we go to 20, and then we should be good. Okay, so 2 fair dice, each with at least 6 faces are rolled. Okay, on each face of the dice is printed a distinct number from 1 to the number of faces. Okay, the probability of rolling a sum of 7 is the 34th probability of rolling a sum of 10, and the probability of rolling a sum of 12 is 1 over 12. Okay, so each has at least 6 faces, right? So we're given that the sum of 7, so 7 could be either 1, 6, 2, 4, 3, 5, 3, what, 2, 5, 3, 4. Okay, that makes a bit more sense. And so on and so forth. So there's basically like 6 options, right? So it's basically going to be like 6 times 1 over n1 times 1 over n2 is equal to 3/4, right? Then for it's 3/4 of the probability of rolling a 10. So probability of rolling a 10. Okay, so essentially like let's say this is the dice 1, dice 2. Then essentially like let's say it can either go all the way to 10, in which case there's 10 options, or it could go all the way up till n1, right? In which case there are n1 options, right? So that would just be n1 over like I mean technically if it's greater than 10, then we'll have to change it, but for now let's just assume that's less than 10 n1, and n2 is greater than 10, let's assume. So from this, it basically says that 6 over n1 is over n1 is equal to 3/4, which basically suggests that n1 is equal to 8. So let's just assume that n1 is 8, and let's see if that works, because that means our assumption here is correct. So we basically got n1 is 8, and we want the probability of rolling a sum of 12. So it goes all the way to n1. Technically, n2 could also be less than n1, but let's just assume that n1 is less than n2 without loss of generality, right? Because we could just say one dice is less than the other. Okay, so then for a sum of 12, you can either go from like, okay, so this also has to be max n2, right? So either like uh n1 or like n2 is big enough so that like 1 and 11 works, or it's less than 11. So if it's greater than 11, then I guess you have like you have n1 options over like n1 times n2 is equal to 1/12, right? In which case n2 is 12, so that technically works, right? But if n2 is but if like let's say n2 is not that big, then it starts from like what? It'll go from, let's say n2 is 10, then it would only start from here. So you subtract n1 minus n2 plus 10, or plus 11, or n2 minus 11, or 11 minus n2. Okay. So if it's equal to 11, you subtract none of them. Okay, so essentially it is n1 plus n2 minus 11 options over, there's 8, so it's just like n2 minus 3 over 8 and 2 is equal to 1/12, right? So if you just solve this, you get 8 and 2 is equal to 12 and 2 minus 36, which basically gives you n2 is equal to 9. So 9 also works, right? So 9 is less than 12, so that's better. And like, assuming that like, and because you can't get any less than like 9, right? Then you know that for the 7 thing, for the 7, for the 10 thing, yeah, for the 10 thing, we know that like it satisfies 1 through 9, right? So that should be fine. So we just sum 8 and 9, and we get 17, which should be the answer. Hey, very nice. So so this is basically what I did without loss of generality. We assume 1 is less. So yeah, there basically must be 6 ways to sum to 10. I mean 8 ways to sum to 10. Yeah, okay, so basically the same thing that we did. Very nice. Alright, and number 20. I think this one was not even that bad. Let's see. So we could literally just like divide it and then just see what happens. So z to the 2021, we're basically trying to find the remainder, right? So z to the 2021 divided by, well, we could put this all the way to the right. We'll just do some long division. Okay, so you do z squared plus z plus 1. And if we just do this, this should be z to the 2019, right? Yeah, z to the 2019. So this is z to the 2021 plus z to the 2020 plus z to the 2019. So then you're left with this cancels out, and you're left with the minus z to the 2020 minus z to the 2019, which means that your next one has to be minus z to the 2018, right? And then that becomes minus z to the 2020 minus z to the 2019 minus z to the 2018, and then these all cancel out, and you're left with z to the positive 2018. And then you're basically back to the same situation here, right? So then you have to do z to the 2016. So you basically get this pattern: 2019 minus z to the 2018 plus z to the 2016 minus z to the 2015. And basically you see the first one is divisible by 3, the second one is not divisible by 3, right? So eventually you're left with like your last thing is going to be z cubed minus z squared, in which case, like, after you do the minus z squared, you're going to be left with minus z to the 4th minus z cubed minus z squared, and then this just becomes z squared, right? So z squared plus 1 divided by z squared plus z plus 1. You just do 1, and then the answer just becomes negative z, right? If you plug this in, z squared plus z plus 1, these two cancel out, and you're left with the remainder of negative z, which is a. Hey, very nice. Alright, that's all I got for you guys today. I hope it was helpful. I will probably do the next 5 because those are the 5 that I did not actually get to attempt. I did attempt number 22, and I got that one right, but I didn't do any of the other 4, so we could live solve them together next time. But anyways, that's all I got for you guys today. Thank you guys so much for watching. As always, if you enjoyed the video, leave a like and subscribe for more. Thank you guys for watching again, and see you guys next time.